If you were to look at a box of a gas, here's what you might see on a molecular level. Just a bunch of gas molecules bouncing around. This is assuming they're not reacting with each other. This is pretty much the total model for gases. It's fairly easy to understand. The kinetic molecular theory of gases is what we call it, and it states that the molecules are just like little points with almost no volume at all. They don't slow down when they hit a wall or each other. We call those inelastic collisions. They're not attracted or repulsed by each other. They just are like a three-dimensional billiard table with no friction at all. And they'll go faster when you heat them up, double the Kelvin temperature, and you'll double the velocity. Let's take a closer look at that because they're not all going at the same speed, and we can consider which ones will go faster, right? The small gases or the large gases, which ones will have more variability as well. We call that a Boltzmann distribution. And this summarizes both of them. Have a good look at this. Pause it if you need to. When we're at a relatively low temperature, the molecules are moving slower. This is all nitrogen, right? They're all the same thing. As we heat them up, they do go faster, but the variability increases as well. They spread out in terms of their velocity. Similarly, if we keep the temperature constant and just go from a heavier to a lighter gas, we see the same thing. The heavier gases, just like the colder gases, are moving slower, and it's a tighter array of velocities. As we make them smaller, they will go faster, but with that, the variability increases as well. We can conclude, 1, the hot gases move faster, the lighter gases move faster, and as you get faster, you get more variability. Or to say it using both variables, you get more variability when you're hotter or lighter as a gas. This is the kinetic molecular theory of gases.